viewing yet, I am so sorry that there was an issue with the join.me link. I have sent you all an email to join me here, but with everything going on with my sister-in-law surgery, I just can't wait any longer to start going through problems. So I'm going to do that. Thankfully, this should be recorded. So you all can view this later. Again, I'm so sorry for the technical difficulties. I'm going to go ahead and turn on my screen sharing. And we're going to start going through problems. All right. Let's get out of that because it just causes video feedback. It's one of the reasons I don't like this YouTube Live. All right. So the first one we're going to go through is Brenda's. Let's hit all of her issues and then we'll move on to Mary Beth's. They were the only two that sent me anything. So you all have them to thank. All right. On problem 1310, the answer check's wrong for the slower copier. She's got $9, didn't include decimals. $9 is not the correct answer for the slow copier. And let me show you why. Find it. Oh, this is Mary Beth's, and I am looking for Brenda's. Okay, sorry about that. All right, slow copier. And what she came up with is $9. So I'm going to look at where she got her numbers from. So what she did is the expected time in queue and multiplied that by the employee cost per hour plus the copier rental costs. Okay. So here is one issue with that. And that is that, well, first of all, think through the question I gave you or sent you in the announcement. Is it costing the company time just while the employee is in the queue, or is it costing the company time the entire time that the employee is in the system? Well, in this case, if an employee is standing by a copier waiting for their stuff, they cannot be productive doing other things. And so the expected time in system is the better number. However, this only gives you the time for one person to go through the system. And you've got 4 per hour that are going through the system. So what you need to do is you need to move that number up there. So now you're referencing B21. And if you want to use the time in system, then you also need to account for the cost or the number of employees per hour, which is 4. Okay. And so now we have the answer 34, and that is the correct answer. Now, if you see this, so the expected time in system is 0.5. The arrival rate is 4. Okay. So if you multiply, okay, 4, I'm just doing this over here. It's not really part of the problem. I just want you to see. If you multiply 4 times 0.5, you're going to get 2. Okay. And so notice how this expected number in system at any given time is 2. That is not accidental. So if you want a one-shop wonder for that, then what you need to do is do B21 times, I'm sorry, not B20, you do B19 times the cost, the waiting cost. And that will also give you 34. Okay, so 34 is the correct answer there. Let me go back and see what else she's got a question on. On 1320, I think the problem is related to macros. And I think Brenda was the one that told me that she was having trouble getting her macros to run. I don't want to do that. Massive video feedback. Okay. No. Okay. There we go. All right. So 1320 and 1321. So let's go look at those. she's got an arrival rate of 50, a service per day rate of 60, and I believe that is the correct model as far as yeah, it is. So I think the issue may be, again, in what number you optimized with. Yeah, so your waiting cost per hour for Brenda, the waiting cost per hour for Brenda is way, way low over here at only $8.30. There is actually a better template for this too than working at from this template. There's a template you can just plug it in. However, we'll go back and work it from this template. So if you've got one server, then your expected number in the system at any given time is 5. Now, we have a question here, and that is, or do we use expected number in queue or expected number in system? I believe for the answer, and I'll work this out, but I believe for the answer check that that they use the expected number in queue. They assume that the customers were happy once they were actually being served, and that it wasn't costing the company any money. So, and again, it's just, that's a little bit of a judgment call, especially in these problems where you don't have a ton of history on the company and the customers to know for sure. An answer that would be obvious for expected, where you would use expected number in queue, would be like a Disney World. While you're in line, you're generally not too happy. Although they've done a lot to make waiting in line more fun at a lot of their attractions. You know, that's not the fun part. The customers are quite happy once they're on the ride, which would be with being served, essentially. That's the entire point of the thing. So their only cost in waiting would be the expected number in queue, not the expected number in system. So again, it's a little bit of a judgment call. All right, so back to this. Yeah, so what was pulled over here is the expected time in queue. And what you want to pull is expected number in queue. And that should be, what did we say? 4.167. And so when we do that, that takes the cost up to $516.70. And so that is actually the correct number. All right. So you would need to do that again with all of these, but the problem was the number. Again, you make sure you use the number in queue, or if you're going to use the waiting time, you've got to make sure you also factor in the number of people waiting, because otherwise you're only calculating waiting cost per person. I would guess there may be the same issue here because these numbers look correct just at a glance. The expected time in the system for a typist in the finance department should be this, yeah, 0.1 of a day. I believe that that is correct. Let me confirm. Yes, that's correct. Finance is 0.1. I'm hoping that this is marketing. Oh, no, I'm sorry. Marketing is 0.1. Finance is 0.2. Yeah, that's correct. So this is finance. It's 0.2. This one's labeled marketing. It's 0.1. So that's correct. When you pool them, let's see if the pool is correct. Yeah, and this pool is actually correct as well. Okay, so the expected time in system is 0.08. 0.078. So that this one looks correct. All right, let's go back and look at her other questions. And 942 and 939. Okay. So let's check the Bayes first. So success, got as favorable and success, you've got as 60, 30, and 10. So these aren't quite right. So let's see if we can figure out. One issue is that you need to be adding by the market outcome, and what you added by was what Brenda added by was a success or failure. So your add should actually be this way in how this is set up. Okay. And then over here, what we divide by would be the success. I'm sorry, what we would divide by would be favorable. That is now 80%. Now that's correct. So the only issue I'm seeing so far in Bayes is that instead of adding down here, you're not adding the success or failures. You're adding together the market, or first you're adding the probabilities that you're going to get a favorable, neutral, or unfavorable recommendation, and then what you do is divide by that. So favorable here. So again, this is still favorable. So this would be divided by this 30. Okay. So this one's neutral. It's going to be divided by the 24%. And so is this one. And 50 is correct there. So you were super close on this, Brenda. And then this one is going to be divided by the 46%. And that's correct. Okay. So there was an issue in Bayes, but so now let's look at the structure of the decision tree and see if how that stacks up. Okay. All right. So the marketing decision, the first thing you've got is, do you do the survey? And that is the correct first decision. Now, once you take the survey, there's a node missing here. There should be a chance node for success or failure. Okay. Then after you have that success or failure node, then you would have another node for a decision, and that would be where you would mark it yes or no. Actually, let me see if I can add. Oh, I don't have this thing plugged into my computer. I need to go ahead and do that. All right, hold on. Gotta start it. Okay. So now, what I actually would like to do is see if we can just add a chance node. Yeah, I can insert node. Okay. And so instead of a decision here, this is going to be a chance. And there's going to be 3 branches, not 2, because you're going to have a chance of favorable prediction, a neutral prediction, and an unfavorable prediction. Now, you would want to put in these percentages from Bayes up here. Okay, so this is where you would use the 30, 24, and 46%. Then for each of these decisions, now you're going to have a yes or no for product marketed. And then you're going to have success or failure. So you'd only have 2 nodes on this chance. And then you would have very different, yeah, so you've got 750 for your success, and I think that's correct. And you lose 450,000 with the failure. But you only need 1 success or failure because you've already accounted for whether it was favorable over here or not, or whatever it was, the prediction over here. All right, so let's look at your no branch. Your no branch here, so no, don't do the survey. Product is, then you have the decision of product market and success or failure. So this one's spot on right here. And just let's make sure it is also the correct, it's also the correct EMV over here. So this bottom part is fine. The other thing is for your test, assume that it costs you $10,000 to administer the survey. So that'd be the other trick to this one. So I think I've figured out everything that was wrong with this one. So I'm going to move on to the next one. All right, 939, it's Bayes' problem. I'm not sure which numbers to multiply. All right, so let's look at 939. All right. Let me grab my textbook and make sure that I start with the correct percentages that you are all using. And what I will do here is I will get you through flipping the inverses. You know that you're working with the correct numbers. All right. So problem 939. Right. So 18% of all cars inspected in Pennsylvania have problems that need to be corrected. Okay. So cars that have problems, 18%. All right. Unfortunately, Pennsylvania's state inspections fail to predict these problems 12% of the time. Okay. So needs correction and detected is 12%. Okay. On the other hand, assume that an inspection never detects a problem where there is no problem. All right. So that would be detected and do not need to correct. So this should be 0, not 100 here. All right. So remember that your inverses come from the actual events, not from the predicted, like in this case, detected or not detected. So what you would do is sum across this whether or not they actually needed correction. So this is going to be 1 minus 12 and 88%. This is going to be 1 minus 0%. Oops. 1 minus, I didn't put the equal. Ha. Right. 1 minus 0%. There we go. All right. So that is your inverses on this problem, is that you will have 88% rate that needs correction and is detected, and 12% that needs correction is not detected, and then 0% that does not need correction is detected and not detected here. So then, of course, what you would do is, actually, I'm going to change this so that the labeling is consistent. So then what you would do for your multiply, I will get you through that much. Actually, do this. Okay. Here is, it needs correction, you multiply that by the 18%. Okay. And then you multiply this one by the inverse. It's still going to be, there you go. Okay. And then remember, what you're going to do the next time is, we've done something not quite right here. Sum to, that should be 1. Oh, I know what we did. Here we go. That's more like it. Okay. So then what we would do is we'd have 15% of cars that have a problem detected, and we would have 84% of cars that have a problem that's not detected. Okay. So then your last step here is divided. I just keep going on this one. I'm going to go ahead and stop here, though. That should be able to get you to where you can finish the rest of the problem. So I think that was all of Brenda's problems. So I'm going to go to Mary Beth's next. Yes, Mary Beth, 0.078 is the correct answer. I'm not sure why that's not telling you that on answer check. I'm so sorry. All right, 468. Not trying to figure out where the number comes from in B26. All right, let's look at that. I love how you highlighted it too. That makes it so easy to know which ones you wanted help on. All right. You actually have 2 or 3 decision variables here, which Mary Beth got. You have the levels of process to use, and then Jenny's advertising hours. So your perfume produced should be, I believe it is a, it's just a sum of the amount used using process 1 and the amount used using process 2. So I just want to confirm that really quick. Oh, wait, no, I'm sorry. It's a sum product of these two, right? Because it is labor hours. Yeah, you're missing a level here, so that should be perfume in ounces. Okay. Because each process produces different ounces. So process 1 produces 3 and process 2 produces 5. So the amount that of your perfume that is produced is going to be in fact, let me see what you did there. I didn't even look before I deleted. Okay, it was just a hard 4,000. Yeah. So that's going to be a sum product of the level of process used and how much each process produces. So now let's rerun and see if we get the correct answer. That is a little bit off still, so let's see if we can figure out where the issue is. Does not have you using any of process 1. Okay. Labor uses 20,000. Used is demand. Okay, let's plug in the correct number. So 270. that is correct. 10,000 and 5,000. Yes, so these numbers are now all correct. So that tells me that the issue is in the in how the constraints were put in. So let's go to solver. So you've got B17 is set to a max. Okay, well that is one issue here. So B17 shouldn't be set to a max. It should be B32. So let's just rerun that without changing anything else. I'm going to zero these out because it looks like that did it. So let me go ahead and zero all of these out and see if it comes up with the same result again. Yeah, there we go. Okay, so this problem now looks correct to me. So there were two issues. First of all, the amount of perfume produced comes from the sum product of the processes used and the ounces produced by that product. And then that the objective cell needed to be B32, not B17. This is a constraint cell, not an objective cell. Okay, so let's go on to 939. Okay, good. That looks good. Cars detected with problems. Let me look at this and make sure. Check this because this may just be a rounding issue. This actually looks very close. Yeah, this is the correct answer right here. Yeah, this is right. So the problem is right. It is 2.567%. The other way that might look is 0.0257. So anyway, this is correct. So it's 2.57% or 0.0257. So great work on this, Mary Beth. All right. Let's see. So 942, let's see. Yeah, I think that the issue with the EMV here, one issue is that the first thing you have is a decision to do the survey or not. So go back and look at what we did on Brenda's because I made sure the structure of her decision tree was right and worked from there. All right, let me check your bays as well. Okay, so an issue with your bays is you actually have three different potential predictions instead of just one. So you do need to redo your bays because this is just accounting for one set of predictions. Like I said, you've got to account for all three. Again, I think it might work. It might help you if you go back and look at Brenda's on this one because we spent quite a bit of time with it. So that would be my best suggestion, so I don't just go back through and repeat it. Y'all, I sincerely apologize. It seems so quiet tonight with just me talking and none of you able to talk back. I'm not even sure if any of you are live. Oh, it looks like I've got 6 of you now, but I don't even have a good way to communicate with you. So I so apologize. I'm going to go and take my thing off screen share so that stop with the video feedback. It drives me nuts. What I will do is I will see if I could ask Syra to be available extra for you all tomorrow if you've got any other questions and such. I would love to do it myself, but with everything going on with my sister-in-law, I'm not sure. I might be able to give it a little bit of time, but I wouldn't be able to give it the same amount of time she will be able to tomorrow. For anybody wanting an update on my sister-in-law, she is, last I heard, she was still in surgery. They were closing, but that was supposed to take a while still. They got most of the tumor. They don't think that she'll have blindness, deafness, double vision like they were concerned about, but she may have some numbness in her face. So we are hoping and praying that that is a temporary thing for her. They will know more, of course, when she wakes up. But I've not even gotten an update that she's in recovery or anything at this point. So this has been going on a 12-hour surgery for her. So be praying for everyone. My in-laws are in their late 80s, early 90s, and they've been at the hospital since like 6 o'clock this morning. So just be praying for strength for everyone. And just, I appreciate your grace with me some this week. And then I wasn't quite as on top of things as usual with your grading. I know it took me a couple of days to get to it. So in any case, I wish you all the best. If you've got questions, you're welcome to email me. And like I said, I will see if I can get Syra to arrange another live session or something with you all tomorrow so you can ask questions in person. And I sincerely apologize that the Join.me platform didn't work for you tonight. I hope everyone has a good night, and I will talk to you later.